talk about the Pythagorean theorem. And what the Pythagorean theorem tells us is if we have a right triangle, we have A and B and C. And we can find this length here, C. And the distance formula uses the Pythagorean theorem because if I have a point here and a point here, I can't, if I'm on a graph, I can't just measure this because it's not even squares, it's cutting across diagonally. But I can measure this flat length and I can measure this flat length, and then I can use the Pythagorean theorem to find this length, the distance between the 2 points. So what happened is I'm trying to find C. And so C is equal to the square root of A squared plus B squared. Well, A, the length of A, is this distance, so it ends up being, so if this is, say, x, y, 1s, and this is x2, y2, oh, sorry, here, x2, y2, I wrote that in the wrong spot. The distance, the length of A, this would be x2, y1. So the length of A is x2 minus x1. And then the length of B is y2 minus y1. And so that gets plugged in to here, and that's how we get the distance formula. x2 minus x1, that's A squared. And then B is y, oh my goodness, this is going to kill me, y2 minus y1 squared. Well, you fill in the points, x and y's. So that's how it was derived. You don't have to be able to derive it. I just wanted you to understand where it came from. This is the distance formula. Okay? So what you'll do, if you want to find the distance between any 2 points, here's point 1 and here's point 2. So you plug in the x's and subtract them and square them. And you plug in the y's and subtract them and square them. And that gives you the distance formula. So that allows you, just ignore this up here. This allows you to find the distance between these 2 points. So you're finding the length here. And so this is the formula that you absolutely need to have in your notes. Just this part right there. What we're going to do is we're going to find the distance between these 2 points. And so you pick, these can be x1, y1, or this could be x, it doesn't matter. You pick, which I always just go in order and say this is the first ones and these are the second ones. But if you like it the other way, you could say these were the 2's and these were the 1's. That's okay. Because the distance will be the same no matter which point you say is the first point. Okay, so the distance is the square root of x1 minus x2 squared, and then y1 minus y2 squared. Now, if you have this one with your seconds, remember that if you minus a negative, it becomes a positive, so don't forget that. So 6 minus 4 is 2, and negative 3 minus 5 is negative 8 squared. And I just want to do something off to the side here. Don't forget, it's important, see how I kept that in parentheses? It's important to keep that in parentheses because if the negative 8 is not in parentheses, this is negative 64. But if the negative 8 is in parentheses, this is positive 64. And the reason being is because an exponent is like a taser. It's only affecting the thing it directly touches. So here it's touching the parentheses, which means everything inside. But here it's only touching the 8, so the negative just gets left alone and hangs out. So there's a difference between these two, and it's a really important difference. So this needs to be inside the parentheses, and when you square it, the other thing to remember is that these numbers that you get after the squaring always have to be positive. So if you forget to put the negative 8 in parentheses and you write down negative 64, remember that they're always positive at this point. Once you've squared them, they're always positive. And so I get the square root of 68. And 68 is 2 times 34, and 34 is 2 times 17. So the square root of 68 is 2 times the square root of 17. And that is my distance. Okay. The reason that I want you guys to practice this is mostly because of the end of course exams. This is a non-perfect square. And non-perfect squares are irrational. And irrational numbers never end. So that decimal goes on forever. So we can never write down the exact decimal answer. So the squiggly line means approximately or almost equals. So distance. That's a 1. So there's your distance formula. So distance between these 2 points, I'm going to call this x1, y1, x2, y2. So I have 3 minus 6 and negative 4 minus 0. So that is the square root of negative 9, negative 3. I was already squaring in my head, I think. So square root of 9 plus 16, which is the square root of 25, which is just 5. The only time you can do that is if the 2 points lie horizontally or vertically. Because I can't count a diagonal. Here, let me pull up a piece of graph paper. It doesn't matter which, like I can say this is x1 or I can say this is x1. Like it doesn't matter which point I say is the first point and which point is the second point. I'll get the same answer. It's just one of them has to be x1, y1, and the other one has to be x2, y2.
So we could do like x1, x2, and the first one.
Nope, x and y.
Okay, and then the second one is
x2, y2.
Okay.
And then you plug those numbers in, so it's x1. I don't like that.
But that's the same way we always follow, right?
Mm-hmm. So x1 minus x2, so I have 11 minus 13 squared plus negative 2 minus 4 squared, which gives me negative 2 squared and negative 6 squared, which gives me 4 plus 36, which gives me the square root of 40. Now 40 is 4 times 10. And I know that 4 is a perfect square. It's 2 times 2. So that perfect square can come out. So this is 2 times the square root of 10. I'll go over that with you.
Okay. Do you only...
The definition of a circle is the set of all points in a plane at a fixed distance called the radius. So here's our radius. From a fixed point called the center. So every point that is this equal distance around is what makes up a circle. So it's not like a bent line or anything. It's actually a set of points. That's the technical definition of a circle. So the diameter of a circle is a straight line.
Is it the whole thing?
Yeah, hold on. Oops, I didn't mean to. I meant to hit this button. A straightish line. Okay, a straight line that passes through the center of a circle whose endpoints are on the circle and it is equal to twice the radius. So here's a radius and here's a radius. And then this whole thing together is the diameter. Okay, so basically it's two radii. That's the plural of radius is radii that are opposite to each other. So they make a straight line.
Do they always equal?
The radius is, no matter where you draw the radius, if I draw radius here or if I draw it over here or wherever, it's always the same length. Okay, same thing with the diameter. If I draw a line through here or through here or through here, always the same length.
Say like the radius equals 50 going across how we have it now.
100.
Okay.
Yeah, you double it. Yeah, and if you have the diameter and you want to find the radius, you divide by 2. Okay. Then that radius, we talked about that already. The radius is the distance from the center to any point on the circle. So we can go anywhere, and this is a radius.
Before you change it, print me a picture at the end.
I'm going to draw them all on the same
Okay.
picture at the end, don't worry. Okay, a chord is a segment which have endpoints that lie on the circle. Here's a chord. And a chord can be any line that touches the ends of the circle. It can also be the diameter. A diameter is a special chord. The diameter is a chord which passes through the center, but a chord doesn't have to pass through the center. It's just any, I can draw a line here,
So
I can draw a line here. These are all chords.
And it won't equal.
It doesn't necessarily, yeah. It can equal anything really, like it just, yes. Okay, so chords are just any line that is inside the circle that touches the two sides. Okay, and it has to touch both sides, or two parts on the circle, I guess, not both sides, but because circles don't have sides. 2 points on the circle. Okay, then we have a secant. A secant is a line. Okay, so if I draw, let me do purple for secant. If I draw a line, this part on the inside, this is a chord. And the line, the purple line, is the secant. So any line that contains a chord is a secant. So any line basically that pierces a circle and actually goes through the circle is a secant line. Okay, so this is like it pierces or goes through the circle.
Only if it's out of
Yeah, it has to, well, a line goes on forever. So here's, this is a, we're going to talk about this too. This is a tangent line. See how it doesn't go through the circle? And a secant line will actually go through the circle. Okay. And like I said, I'll draw all these onto the same circle in a second. I'm going to, yeah. And then a tangent touches the circle, but it touches in only one point. Okay, so a secant line goes through the circle, a tangent just touches the circle. Okay, so, oops, right. So let me draw them all really quickly, and I will pull that back up in a second. There we go, that's everything all together. All right. So circles can be represented in different ways. If we take this circle that is centered on the origin, okay, this point, the 0, 0, is called the origin. Okay, and if we have a circle that's centered on the origin, we're looking for this distance. Well, we already know the distance is 5. So remember our distance formula? If I plug in and I say this is x, actually, you know what I'm just going to do? I'm going to say this is x1, x1, y1, and this is x2, y2. So I'll have x minus 0 plus y minus 0 And that gives me x squared plus y squared. That's the distance. Well, if I put the 5 in, and then I want to get rid of the square root, so I would square both sides to get rid of the square root, and I would get 25 is equal to x squared plus y squared. And this is the equation of this circle. So if I have a circle at the origin, okay, 5 is what would you call this line right here? So it goes from the center to the side. It's a radius. So the equation of a circle centered on the origin is x squared plus y squared is equal to r squared, where r is the radius. Okay? So if you know you're centered on 0, 0, that's your equation for that circle. So all you have to do is find the radius and plug it in. Okay, so when you're not centered on the origin, so here I'm centered off the origin, I'm centered at -2, -3. So if I call this
So
x1, y1,
y1.
still the same radius, it's just moved.
Yeah, but there's that 5 next to it.
Yeah, that's the radius,
okay.
yeah. So if I plug this into the distance formula, I'm just going to go ahead and rewrite it because you guys need to learn it. So, okay, x1 I have is x, and x2 is -2, and y1 is y, and y2 is -3, and my distance is 5. So I get x plus 2 and y plus 3, but I can't do anything with that. And if I square these to get rid of the square root, I get that 25 is equal to x plus 2 squared plus y plus 3 squared. Now, that's the equation of this particular circle. That's this circle right here. The general equation of a circle not at the center, HK, is what we call this point right here. So the center is HK. All right, so instead of saying x1, x2, y1, y2, we're going to call them HK now. And so the standard form, so the regular equation of a circle with some center anywhere, is x minus h, y minus k is equal to r squared. X and y stay letters. H and k ends up being the numbers here, and then r is the radius. So I'm going to actually show you how that works with real examples, don't worry. Then it would be a circle over here. You'd be talking about the wrong circle, because H and K has to be the center, always the center. Yeah, the C means center, yeah. Now if you put 1 and 3 in here, there is a circle that exists. That would be the circle you're talking about, though. You're talking about the wrong circle at that point. Yeah. Yeah. So, circle formula. A, relatively simple. This is a plug-in situation. B, we have to find the radius first. C, we're finding the diameter. Oh, I guess I lied. There's one more step. Okay, C we'll do together. And then D. tangent to the x-axis. Do you remember what tangent means? It just touches. Okay, so what we've got is we've got, say, some circle that's at negative 5, 3. So that's going to put it somewhere over here. And it's going to touch the x-axis at one point. And that point is going to be negative 5, 0. And I know it's 0 because it's on the x-axis, right? So it's not going up. And I know it's negative 5 because I was told negative 5 here. So this is my second point. Do I need to calculate this distance right here between negative 5, 0 and negative 5, 3? It's 3. So the radius would be 3. So if you have tangent to the x-axis or tangent to the y-axis, you can figure out the distance by just, and sometimes it helps to maybe draw a rough sketch so you can see what's going on. But since this point was negative 5, 3, and here's 0, I went up 1, 2, 3.
You always start up.
If you're tangent.
Tangent means
Well, if you're tangent to an x-axis or tangent to the y-axis, that means
zero.
one of your points are going to be 0.
Okay.
Yeah. So if I was tangent to the y-axis, let me just draw that. If I was tangent to the y-axis, say I had the same point, negative 5, 3, but I was tangent to the y-axis. So this would be negative 5, 3. This point would be 3, 0. So my distance would be 5, because I'd have to go 5 over to get to the negative 5. So if you're tangent to one of the axes, it makes it really easy to find the radius. It'll say center, and then it'll say tangent to x-axis or tangent to y-axis.
It'll give us that other number.
No, it won't.
Oh.
See, but if it's touching the y-axis, I know the y-coordinate.
Oh, okay.
And
Like
here it was
right
touching the
above.
x-axis, so I knew the x-coordinate. Does that help?
Yeah.
Okay. So this one will be a relatively simple plug-in. This one will be a relatively simple plug-in. This one we have to find the radius. So let's talk about C. Okay. I have the endpoints of a diameter. And those are 2, negative 1, and 10, 5. Okay, so what this looks like is I have a circle, and I have a diameter with points. I know that this is not like lined up properly, but whatever. 10, 5. And so here's my diameter. My center is what special point on that line? If I have a line segment, okay, well, if I have a diameter, what length is the radius? Half. So if I have a diameter, what's the center point? It's the center of the circle, but if I have a segment, what's the center point called?
Well, I know. Sometimes you can do like that. I'm thinking of midpoint.
Midpoint, exactly. The midpoint is going to be the center of the circle. That's exactly right. It's the midpoint. So we have to find the center of the circle to be able to find H and K. So the first thing here, we have to find the midpoint. That's a 1, which equals our center. And then after that, we have to find the length of the radius. And then after that, we plug in. Okay, so this one would have 3 steps. So it's all the same equations. So this one, like I said, this one's an easy plug-in. I have my center, x minus 6, y minus negative 8 is equal to 4 squared. And that will simplify to x minus 6, y plus 8, and 16. Okay, so A is the easiest one. D wasn't a lot harder because it was tangent, so we were able to calculate the r really quickly, and then it becomes a plug-in. So I have x minus negative 5, y minus 3 is equal to r squared. So the equation is going to be x plus 5, y minus 3 is equal to, that was a 3, 9. Like I said, it's B and C that are going to take the most. We've already done one like B, and we're kind of running short on time, so I'm going to do C first, and then if we have time, I'll do B. Okay. But before I move to that, okay, first I have to find the midpoint. So midpoint formula is x1 plus x2 over 2, y1 plus y2 over 2. So 2 plus 10 and negative 1 plus 5. So 12 divided by 2 is 6. 4 divided by 2 is 2. So that's my center. So I'm going to label that as the center, and so that makes that H and K. Okay. Point 2, I need to find my radius, which means I need to use that distance formula. Now, I'm writing out every single step on these typically. There's a lot of this that you'll be able to do without writing everything down. Yeah, it is a lot of formulas. Yeah. So here I'm going to use the center because I'm trying to find the radius. So I need to use the center and 1 point. And it doesn't matter. I can use this point or I can use this point. Which point would you like to use? 10, 5. Okay, we're going to use 10, 5. So I'm going to say 6 minus 10 and 2 minus 5. So that gives me negative 4 squared and negative 3 squared, which gives me 16 and 9, which gives me the square root of 25, which I know is 5, but I'm not going to bother with it because I'm just going to end up squaring it anyway. Right? So then for 3, being backwards.
So you can pick either endpoint.
Yeah, I can pick either endpoint. It doesn't matter because the radius is the same distance no matter which side I go to. Yeah, so I would get the same 25. Okay, so I know my center. So I have x minus 6, y minus 2, and the radius squared is the square root of 25 squared. So that's just 25. And so there's my circle. Okay, and that's the most you'll ever have to do on these.